A potential hazard for any space mission, including NASA's Mars Sample Return, is micrometeorites. These tiny rocks can travel up to 50 miles per second, 180,000 miles per hour. At these extreme speeds, even dust could cause damage to a spacecraft, said Bruno Sarli, NASA engineer at NASA's Goddard Space Flight Center in Greenbelt, Maryland. Sarli leads a team designing shields to protect NASA's Mars-Earth entry system from micrometeorites and space debris. To test the team's shields and computer models, he recently traveled to a NASA lab designed to safely recreate dangerous impacts, set far away from residents and surrounded by dunes. The Remote Hypervelocity Test Laboratory at NASA's White Sands Test Facility in Las Cruces, New Mexico, has supported every human spaceflight program from the Space Shuttle to Artemis. The lab also supports testing for the International Space Station, ISS, commercial crew, and commercial resupply programs. Two-stage light gas guns are used by the lab to accelerate objects to speeds up to 27,500 feet per second, 18,750 miles per hour, that simulate micrometeorite and orbital debris impacts on spacecraft shielding. The first stage uses gunpowder as a propellant the way a standard gun does. The second stage uses highly compressed hydrogen gas that pushes gas into a smaller tube, increasing pressure in the gun, like a car piston. The gun's pressure gets so high that it would level the building if it were to explode. That is why we hung out in the bunker during the test, said Sarli. NASA's Remote Hypervelocity Test Laboratory is equipped with 4 two-stage light gas guns, two 0.17 caliber, 0.177-inch bore diameter, a 0.50 caliber, 0.50 bore diameter, and a 1-inch, 1.00 bore diameter gun at the facility. The 1-inch range is 160 feet long, from the gunpowder breech to the end of the target chamber outside. Credit: NASA's Goddard Space Flight Center. Engineers spent 3 days preparing for an experiment that lasted just 1 second. They used the lab's mid-sized high-pressure, 50-caliber range, two-stage light gas gun that shoots small pellets at speeds of 16,000 to 22,000 feet per second, 11,000 to 15,000 miles per hour. At that speed, you could travel from San Francisco to New York in 5 minutes, said Dennis Garcia, the .50 caliber test conductor at White Sands. While the pellet's speed is incredibly fast, micrometeorites actually travel 6 to 7 times faster in space. As a result, the team relies on computer models to simulate the actual velocities of micrometeorites. The slower rate will test their computer model's ability to simulate impacts on their shield designs and allows the research team to study the material reaction to such energy. Mars Sample Return is a multi-mission campaign designed to retrieve scientifically selected samples of rock and sediment that NASA's Perseverance rover is currently collecting on the surface of the Red Planet. Bringing those samples to Earth would allow scientists to study them using the most advanced laboratory instruments, those that will exist in the coming decade and those in the decades to follow. The campaign is one of the most ambitious endeavors in spaceflight history, involving multiple spacecraft, multiple launches, and multiple government agencies. Goddard is currently designing and developing the capture, containment, and return system that would deliver the Mars sample tubes back to Earth.